Welcome to educator.com. In this lesson, you will be learning about subtracting integers. There are a lot of applications for subtracting integers. For example, in measuring a diving submarine, the depth of a diving submarine, or in looking at falling temperatures. Vocabulary for this lesson are integers and opposites. Integers are positive and negative whole numbers, and including 0. So some examples of integers would be -3, -2, -1, 0, +1, 2, and 3. And it continues. Opposites are numbers that are the same distance from 0 but on opposite sides of the number line. So for example, opposites would be -3 and 3, or -2 and 2. Each of these numbers is the same distance from 0, but on the opposite side of the number line, on the opposite sides of 0. Notice that integers are all numbers and their opposites, including 0. In order to subtract integers, we have to know the rules for multiplying signs. A negative times a negative is a positive. A positive times a positive is a positive. A negative times a positive is a negative, and a positive times a negative is a negative. You'll notice that whenever you're multiplying signs that are the same, for example, a negative times a negative, or a positive times a positive, your answer is positive. And whenever you're multiplying signs that are opposites, a negative times a positive, or a positive times a negative, your answer will be negative. Let's try subtracting integers using a number line. Here is 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and -1, -2, -3, -4. All right, our example is 2 minus 5. I'm going to start out at +2. Next, I'm going to subtract 5, -5. This means move in the negative direction on the number line 5 units. 1, 2, 3, 4, 5. And I end up at -3. So 2 minus 5 is -3. Here are some more examples using a number line. First, we want to think about what the double symbols next to each other mean. This means to subtract -13. So when you're subtracting -13, it also means that you are adding the opposite. So in this case, 10 plus 13. So if I were to start at 10 on the number line, there's a lot of numbers to write for this one. All right, at the end here. So if I'm going to start at a +10, instead of subtracting 13 and going backwards, I have a double negative. This means that I'm going to be moving in the positive direction 13 units. So start at 10 and add 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I end up at 23. So 10 minus a -13 is 23. Remember the rules of multiplying signs. A negative times a negative becomes a positive. Let's try another example of subtracting integers by rewriting using absolute value. If I rewrite this by taking care of the double signs here, a negative times a negative is a positive. So I now have negative 19 plus 12. I'm going to find the absolute value of negative 19. That is 19. And the absolute value of 12. That is 12. Subtract the numbers. 19 minus 12 is 7. And then I'm going to go back and see which number had the larger absolute value. Negative 19 did, with the absolute value of 19. And negative 19 in the problem has a negative sign. So my final answer will be negative 7. So negative 19 plus 12 is negative 7. Here's another example with a lot more signs. Let's start off by simplifying all the double signs, making the expression easier to look at. Negative 18, negative times negative is a positive 54, and then negative times negative is a positive 38. When you're adding and subtracting integers, make sure to always move from left to right. So let's start off by evaluating these two numbers. Negative 18 plus 54. 54 minus 18. 14 minus 8 is 6. And we've borrowed, so now 4 minus 1 is 3. So negative 18 plus 54 is 36. And bring down whatever parts of the expression you have not used yet. So lastly, all we have is an addition problem, 36 plus 38. Carry the 1, and we have 74. 36 plus 38 is 74. So quick recap. When you have a longer expression like this one, you want to go through first and simplify the expression by rewriting the signs. The negative and the negative became the positive, the negative and the negative became the positive. Now, using order of operations, move from left to right. Make sure to always bring down the parts of the expression that you had not yet used. In the case of having really long expressions, it can be easy to leave out part of it. Let's try a word problem. The temperature was 3 degrees Fahrenheit. By midnight, the temperature had dropped 8 degrees Fahrenheit. What was the temperature at midnight? So we want to use integers to represent the temperature. When we started measuring, it was 3 degrees Fahrenheit, so that's a positive 3. By midnight, the temperature had dropped 8 degrees Fahrenheit. Dropping means moving downwards on the thermometer, so that would be represented by negative 8. 3 minus 8 is negative 5. So the temperature at midnight is negative 5 degrees Fahrenheit. Let's look at this using a thermometer. If you have 0 degrees here, and we start out at 3 degrees, it says that the temperature dropped 8 degrees Fahrenheit. So we have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So we're starting out at positive 3. Now let's drop the temperature 8 degrees. 1, 2, 3, 4, 5, 6, 7, 8. So we end up at negative 5. So the temperature is negative 5 degrees. Here's another word problem. A fish was 1,865 feet below sea level. It then swam down to 2,434 feet below sea level. What was the fish's change in depth? So let's create the situation. The fish is down in the water, so it would be below the water line, so that's going to be represented by a negative number, 1,865 feet. It continues swimming downwards until it hits the level of 2,434 feet. It started out at 0. That's the water line. So at this point it is, let's write it next to the water level. At this point it is at negative 1,865 when we first started. It kept swimming downwards and ended up at negative 2,434 feet. So what is this change from where the fish first started swimming to where the fish ended up? Let's find how far down the fish went. So you're going to take 2,434, which is the fish's final resting place, and subtract where he started out. So 14 minus 5 is 9. We borrowed. 12 minus 6 is 6. We borrowed. 13 minus 8 is 5. And we borrowed. So from negative 1,865 feet, the fish swam down another 569 feet to reach its final resting place at negative 2,434 feet. So the fish's change in depth was negative 569 feet. Remember that the fish is moving downwards, so the integer needs to represent the negative movement. On the first play, the football team lost 5 yards. On the second play, the team lost 8 yards. What was the total change in yards? So the football team loses 5 yards. That would be represented by the integer negative 5, the loss. On the second play, the football team continues losing yards. And that is also represented by negative 8. So the football team has been moving backwards away from its goal on the field. And it's been moving in the same direction. So let's combine these numbers. 8 plus 5 is 13, and it's lost a total of 13 yards. Thank you for watching educator.com.